Okay, we'll come back to my scratch and I'm doing more problems here. And we are still working on the acceleration. The problem number 10 says a brick falls down from a building of height h if the total time it takes to reach the ground is capital T. How much time has elapsed when it is halfway down the building? Ignore air friction. So if I want to find how long does it take, how much time, then first thing I will try to find the relation between the distance and the time. So we'll use the equation of motion that says that d equals to v initial t plus half gt squared. Now the initial velocity is 0, so it's 0 plus half times 9.8. And it says that the total time it took to reach the ground is capital T. So now I'll replace small t with capital T, so it becomes capital T squared. So now we know that the distance equals to half times 9.8 times capital T squared. So what should be the time if d becomes d over 2? So now I'll say d over 2 equals to half, equal to 0, which is the initial velocity, plus half times 9.8 times the time. Now we want to find this time, t squared. But remember, we know that d from the first part equals to half times 9.8 times capital T squared. So now I will replace d with this, which will equal to 1 over 4 times 9.8 times capital T squared. That's equal to half times 9.8 times t squared. Now we can cancel 9.8 with 9.8. We end up with t squared equals to capital T squared over 2. Then you can solve for t, and t equals to 0.71 times capital T, and the answer is A. Let's go to number 11. It says that a rifle is aimed horizontally toward the center of a target 100 meters away. If the bullet strikes 10 centimeters below the center, what is the horizontal speed of the bullet? Ignore air friction. So this is another problem about the projectile motion. And the first thing I want to find is how long does it take for the bullet to reach the ground. So we will use this equation that says d equals to v initial t plus half gt squared. Now d is the height, which is 10 centimeters. And 10 centimeters means 0.10 meter. The initial velocity is 0. Now remember that this initial velocity is the initial vertical velocity and not the horizontal velocity, plus half times 9.8 times t squared. Now I can find t, which will be 0.14 seconds. So it means that it will take 0.14 seconds for the bullet to hit the ground. Now we want to find what is the horizontal velocity. Now remember that to find the horizontal velocity, I must use the horizontal distance. So I have velocity equal to distance over time. The distance is 100 meters and the time is 0.14 seconds. Now I can find the horizontal velocity, which would be 714 meters per second. Now we can move on to the next problem, and it says a boy releases a bowling ball from rest. It rolls down a ramp with constant acceleration. After half a second, it has traveled 0.75 meters. How far has it traveled after 1 second from the start? This is pretty easy. So we can just use the equation of motion that says d equals to v initial t plus half a t squared. Now the distance is 0.75 meters and the initial velocity is 0 plus half multiplied by the time. The time is half a second. So that can give me the acceleration, which is 6 meter per second squared. So what if I need to find what is the distance not after half a second but after 1 second? Then in this case I can just reuse the equation d equal to v initial t, again v initial is 0, plus half times the acceleration now is known, which is 6 multiplied by 1. That gives me 3 meters. This is very straightforward. Now let's move on to number 13, and it says that a train going from one station to the next on a straight section of track accelerates from rest at 1.1 meter per second squared for 20 seconds. It then proceeds at a constant speed for 1,100 meters before slowing down at 2.2 meter per second squared until it stops at the station. How much time does it take for the train to go between the stations? So we want to find the total time for the train to go between the stations. Now, I know for the first part, the time is 20 seconds. So I already know for the first part, the time is 20 seconds. But I need to know what is the train's final velocity after those 20 seconds. So I will use this equation that says v final equals to v initial plus at. Now what is the v initial is 0, and what is the acceleration is 1.1 meter per second squared, and the time is 20 seconds. So now we know that the final velocity is 22 meters per second. Now for the second part, this final velocity will be the velocity of the train. So I want to know how long did the train move with this velocity, which will be constant for the second part. So we know the distance is 1,100 meters. So if I divide this by 22 meters per second, that gives me the time, because we know that velocity equals to distance over time. So time equals to distance over velocity. So for the second part of the trip, the time is 50 seconds. So what about the third part? For the third part, we know that the final velocity is 0 and the initial velocity is 22 meters per second, because this is the velocity at which the train was moving at, minus the acceleration, which is 2.2 meters per second. Now why minus here? Because the train is slowing down. Then I can calculate the time, and the time will be 10 seconds. So what is the total time for the trip? It is 20 seconds plus 50 seconds plus 10 seconds. So it will be 80 seconds, and the answer again here is A. Now let's check number 14. And it says the graph below shows a speedometer reading obtained as a skateboard travels along a straight line path. How far does the board move between t equals to 1 second and t equals to 5 seconds? So the speedometer is the device in your car that measures your speed. And we want to know what is the distance between 1 and 5. So guys, remember I told you before, maybe in the last video, that if you see a velocity time graph and you want to find the distance, then you must find the area under the graph. But I only need to find the area between 1 and 5, because this is what I want to know, between 1 and 5. So between 1 and 5, I can split the area into these three different areas, B, C, and D. So I have a rectangle, another rectangle, and a triangle. So for the first rectangle, the area should be, I have the width times the length. So between 3 and 1, that is 2. 2 times 4, that will be 8. So the area here is 8. For the part C, I have 5 minus 3, that is 2. And 2 times 6, that would be 12. For the part D, and I have, it's a triangle, right? So the base is 3 minus 1, that's 2. 2 times 2, that is 4, times half. Because remember, the area of a triangle should be half base times height. So it becomes 2. So what is the total area? it is 20 plus 2, that will be 22 meters. So this will be the displacement, it will be 22 meters. Okay, so now we can move on to the next problem, and it says that a car going initially with a velocity 13.5 meters per second accelerates at a rate of 1.9 meters per second squared for 6.2 seconds. It then accelerates at a rate of negative 1.2 meter per second. That means that it slows down until it stops. What is the total time from the start of the first acceleration until the car is stopped? Okay, so first thing I need to find what is the final velocity after the first part of the trip. So V final equals to V initial plus AT. Now what is the V initial? It is 13.5 meters per second. And what is the acceleration? 1.9 meters per second square. And what is the time? 6.2 seconds. So the final velocity becomes 25.28 meters per second. Now for the second part, the final velocity is 0, the initial velocity is 25.28, and the acceleration is negative because it slows down, so it's a negative 1.2 times t. Now you can find the time again, which is 21.06 seconds. So the first part, I have the time 6.2 seconds that is given in the problem. For the second part is 21.06 seconds. Now I can add these two together. It gives me the total time, which is 27.26 or 27.3 seconds. And now let's check number 16. It says that a ball rolls off a horizontal table at 0.3 meter per second and strikes the ground 0.15 meter horizontally from the base of the table. How high is the table? Now this is another problem about projectile motion. So you have a ball that is moving horizontally at 0.3 meters per second. So now that means that the vertical velocity is 0 and the horizontal velocity is 0.3 meters per second. We want to find the time to reach the ground. Now remember that if you want to find, we need to have the height of the table. So first I need to find the time to reach the ground, and we know that this distance equals to this velocity multiplied by the time, because velocity equals to distance divided by the time. So the time equals to the distance divided by the velocity. Now the distance is 0.15 meters and the velocity is 0.3. Now here I have to use the horizontal velocity, and because I'm using horizontal distance, so in this case the time will be 0.5 seconds. Now to find the height, you must use the vertical velocity. Now the height equals to the v initial t plus half gt squared. Now the v initial is 0 plus half times 9.8 times 0.5 squared. That gives me the height, which is 1.225 meters or 1.23 meters. So remember, I have used the horizontal distance and the horizontal velocity to find the time. Then I use the time here to find the height. Now let's move on to number 17. It says that the graph below shows the speedometer reading obtained as the skateboard travels along a straight line path. How far does the board move between 3 seconds and 6 seconds? So I guess we have solved something similar before, but we need from 3 to 6. So again, I told you, if you see the velocity time graph, then you must find the area under the graph. Again, here we need only to find the area between 3 and 6, and I can easily split this into 3 areas, A, B, and C. I have rectangle, another rectangle, or a square, and a triangle. So if I want to find the area A, it becomes 5 minus, that's 2, 2 times 6, that will be 12. And for the area B, it's 1 times 1, that is 1. And for the area C, 6 minus 5, that's 1, times the height is 5. And then 1 times 5 is 5, times half, because it's a triangle, so it's a half times base times height, that will be 2.5. Then you add these three areas together, A plus B plus C, that gives you a 15.5, which is A. Now the next problem, number 18, it says in which case the acceleration of a car is perpendicular to its direction of the motion. Now you can see here the answer is A, because if we have a circular motion, we said that if you have an object moving at a constant speed in a circle, then it will be affected by an acceleration, which is the centripetal acceleration, and it's towards the center of the motion. And this centripetal acceleration will be perpendicular or 90 degrees to the velocity. So the correct answer here is A. And now we go to number 19. You throw a ball downward from a window at a speed of 2.0 meters per second. How fast will it be moving when it hits the sidewalk 2.5 meters below? So again, that's very straightforward. So I just need to use the v final squared equal to v initial squared plus 2gd. Now, because the ball was thrown, it was not dropped. It was thrown at 2 meters per second. So 2 squared becomes 4 plus 2 times 9.8 times the distance, which is the height here. It's a 2.5 meters. So it gives me the v final squared. Using my calculator, I can find the square root of v final squared, which would be 7.28 meters per second. Now next one, it says that a bullet is fired horizontally from a rifle at 200 meters per second from a cliff above a plane below. The bullet reaches the plane 5 seconds later. How high was the cliff? Okay, so here I just need to use this equation. Says height equal to v initial t plus half gt squared. Now here it says that the bullet was fired horizontally at 200 meters per second from a cliff. Now that tells me that the horizontal velocity is 200 meters per second, but it also tells me that the vertical velocity is 0. So here it becomes 0 plus half times 9.8 times the height, which is times the time, which is 5 seconds. So it's a 5 squared. So you multiply these guys together, you get 122.5 meters. Now we can move on to the next problem that says a car starts from a position of 10 meters east of a post office at a velocity 12 meters per second east and moves as shown in the following velocity graph. What is the car's position relative to the post office at time t at time 4 seconds? So here we have a nice graph, which is again another velocity time graph. Now you can see that I want to find the position of the car at 4 seconds. As I told you before, that if you see velocity time graph, then try to find the area under the graph during the period that you are studying. So here I have two areas, A and B, and for the area A I have a triangle, B I have another triangle. So I have half base times the height for the area A, which is 3 times 12, that's a 36, divided by 2, that will be 18. And for the area B, if it is 1 times -4, that's the -4 times half, that would be a -2. So when you add these two together, it gives you 16. But remember that 16 is not the correct answer because this car did not start from 0. It started from a position 10. So I need to add 16 plus 10, that gives 26 meters. Okay, now the next problem, number 22, it says that the takeoff speed of an Airbus A320 jetliner is 80.5 meters per second. That is the takeoff speed. Velocity data measured during the takeoff are as shown in the figure or in the table. At what time do the wheels leave the ground? So when they say at what time do the wheels leave the ground, it means at what time the airplane takes off. Now if I look at this data, you can see time and velocities, and you can see 0, 10, 20, 30, and I have 0, 23, 46, 69. Now if you look carefully here, you will notice that the difference between the 23 and 0 is 23, between 46 and 20 another 23, 69 and 46 another 23. So it means that the velocity of the airplane increases by 23 meters per second each 10 seconds. So it means that when the time is 40, the velocity must be 92 meters per second, which is 69 plus 20 plus 23. But I don't need at but none of the answers here. Actually, no, we have 40 is one of the answers, but 40 is 92 meters per second, which is way more than 80.5. So what I will do is I will check 30 is less than the takeoff speed and 40 is more than the takeoff speed. So what I will do is I will try to find 35, which is between 30 and 40. So I can do it in many ways. I can find the average of 69 and 92 over 2 that give me the time, the velocity at time 35, which would be, wow, 80.5 meters per second. So it means at 35, at 35 seconds or after 35 seconds, the plane can take off because it will have the proper takeoff speed, 80.5 meters per second. Okay. Let's see the next problem. It says that three balls of different masses are shown horizontally from the same are thrown horizontally from the same height with different initial speeds, as shown in the figure. Rank in order from the shortest to the longest the time the balls take to hit the ground. Now remember, if you want to find the time does not depend on the horizontal velocities. The time depends only on the vertical velocities. And as for these three balls, they all have the same initial vertical velocity, which is 0 meter per second. It doesn't matter what is the horizontal velocity here. What matters is the vertical velocity, because time depends on the vertical velocity. That's why the correct answer is A, T1 equals to T2 equals to T3. Now the next problem, number 24, it says that an elevator is moving downward. It is slowing down as it approaches the ground floor. Which of the following velocities or velocity graphs represent the motion of the elevator? So now I have the elevator that moves down and it also slows down. Okay, so first thing, we need the elevator to slow down. Now as you can see here in the part A, the elevator speeds up, so I should not take this one. Also here at the part at the last graph, you can see the velocity is increasing in the negative direction, or increasing down. So this is not also the right answer. So the answer could be either 2 or 3. Now in 2 you can see the velocity decreases with the time, but the velocity is plus. But I want the elevator to move down, so it means that it must have a minus velocity. So the only option left here is this, because the elevator slows down and it's also moving it's also moving in the negative, so it means that it moves down. So the correct answer here is the answer A, which means that the right graph that represents the motion of the elevator is the graph number 2. Okay, now the next question says that a football is kicked straight up into the air. It hits the ground 5.2 seconds later. With what speed did it leave the kicker foot? Okay, so the idea is someone kicked a ball, the ball moved all the way up, then it moves down again, and they want to know what is the initial velocity. Um, uh, I need to know what is the initial velocity of the ball, right? And here we use this equation that says d equal to v initial t plus half gt squared. Now remember that v initial, or v0, is what you need, multiplied by 5.2, which is the time, minus half times 9.8 times the time, 5.2 seconds squared. But you will notice here that I put 0 for the distance now, because this d is not the distance, this d is the displacement. And if the ball starts from here, from the ground, and ends back at the ground, then the total displacement is 0. So that's why I put it 0. Then you can find the v0 equals to 25.48. So this is supposed to be v0, sorry for that, it's not t, it's supposed to be v0, or v initial, equals to 25.48 seconds. Now you can also solve this problem by splitting it into two parts. So you can take from the beginning to the highest point, then you can find the velocity at the highest point, and then you can find because if we know the velocity at the highest point, and we know, because at the highest point the velocity is 0, right? So you can find the initial velocity using the gravity and using the time. But in this case we don't know the distance. Okay, so anyways, I will just think about another way to do this, but for now you can just use this method, which says d equal to v0t plus half gt squared, and then you can just find the initial velocity. Okay, so I guess we'll just stop here, and we'll see you in another video soon, inshallah. Thank you.